Intrumentation. I'm Jeremy Brown.
I'm Shih.
Karsten.
Yeah, this is our project, wireless I/O module.
So our trainer consists of a wireless I/O, a K-type thermocouple, an amplifier, a fan, and a heat gun.
So at the trainer unit, we have a heat gun that we're going to use to heat up the thermocouple. Our program is on a separate computer across the room. So it has a modem over there that catches the signal from this wireless I/O module. So as it heats up, there's a small voltage made at the thermocouple that is put through to the thermocouple amplifier. That signal is filtered with an RC filter, as you can see there, and then is input into an analog input to the wireless I/O module. And that signal is sent to our modem across the room, and the modem receives it as a signal from 0 to 5 volts.
The trainer was constructed by first cutting a hole of 11.5 diameter circle into the side and screwing the fan on, and the other side a square opening for the airflow, and the thermocouple is just inserted in through a side hole that I drilled.
So as the signal comes from our trainer unit, which is across the room from the radio communication, it is received by the modem here, which is hooked up as a RS-485 3-wire. We have it hooked into the PLC according to this schematic here, as seen in our binder. The signal goes to port 3 of a click PLC, which is the 485 communication Modbus, and we have a program in that click that receives the signal and can send the signal to turn on the fan. So our click program is seen here on the screen. Our first is the send command. On both the send command and this receive command, we have to use Modbus hex addressing, which is offset by 1. We had to make sure to set the correct baud rate and parity bit to the correct setting. So this is the Modbus hex addressing that's in the registers of the radio modem. Our raw data is seen down here, is DS35. That's the data that comes from the modem, which is for 0 volts coming over is 0, for 5 volts it comes over at 4095. So we have to use this DF10, we have to use it up here in our math function to change it to an actual Celsius temperature that we can understand. And then we also have from Celsius to Fahrenheit there.
The resulting value from our math functions is a temperature in degrees Fahrenheit. Right now it's displayed as a floating point number, and in order to write it to a input register, we had to convert it to an integer value. So right here we have a copy from floating point to our input register, an integer value, which is then sent via Modbus to the LabVIEW program, and it's displayed right here as a digital indicator, which actually displays the value that was received from Modbus. The functioning of the LabVIEW program is to compare this temperature value to a preset set point, which the user can adjust right here on the LabVIEW program. Basically, if the temperature of the thermocouple is higher than the set point, then it will call for the fan to come on and to cool it off. And as long as the temperature is below the set point like this, the fan won't be active. But if we change this to a set point lower, then it will turn the fan on. It does this through the LabVIEW program. Here's the ModView, the Modbus VI. You start with this Modbus initialize command, which there you set your COM port, your baud rate, your parity, your timeout. You set your slave address, RTU protocol. And then inside the loop here we have our read input registers, which is where we read the temperature value through RS-232 communication from the click. And over here is write single register, where we will write either the value of 1 to turn the fan on, or if it's false, we write the value of 0 to turn the fan off. We've also incorporated a manual control switch for the fan, which is controlled right here, which basically just makes the statement true and writes a value of 1 to the input register, which is sent to the click program and then sent back to the wireless I/O.
As Eric was talking about earlier, the LabVIEW program is going into our click PLC in port 1 with the RS-232 wire, and from port 3 of our PLC we use a 3-wire RS-485 to go into the modem. From our modem we are wirelessly connected to the I/O, which sends a radio signal that can turn on the fan.